Okay, so we're recording. So here's the deal. If anybody is watching this video, please tell me someone's watching this video. We had some issues with the recording and we're redoing the whole thing, like from scratch. But I will tell you, for this webcast, a couple of things. One, we are going to use PowerPoint. We realize that PowerPoint is important and PowerPoint is good. And we're going to need PowerPoint to explain different stages as far as where we're at. I've seen the errors of my ways, and PowerPoint is just the way we're going to do things. So what we're going to do in this webcast is Kent and Jordan are going to walk through an example of a relatively basic penetration test. And we're going to go from the beginning all the way through to the end where we get domain administrator. If we have time, we're going to exfiltrate and pilfer data out of that environment. I will be asking questions. Here's the deal. We actually have, I'm not kidding, 600 questions from the attendees. I'm not going to ask every one of those questions. I may pick some out every once in a while and throw those in, but I'm not going to ask the 600 questions that people asked. So we're going to redo this. We're going to kick it up. And this isn't the slide we start on. We start on the next slide, on slide 2.
No problem.
And so this is Attack Tactics 5. Yes, Jordan.
I would also like to point out something about this webcast. In one 24-hour period, we have broke multiple BHIS webinar records. The first one yesterday, max attendance, largest webcast in our history. Today, the smallest.
It
is. Is it 3 or 0?
I think we're at 3. I don't even think Jason's on.
Jason's gone.
If you're watching this video, if we seem a little like a shell shocked, it's because we had 1,000 people live, and I had about 200 angry emails from people that were not able to get on the webcast. So this is for everyone out there. We always record this. So if you're watching this, and of course, if you're watching this, it's a recording. So I shouldn't answer the question, will this be recorded? Because they're watching a recording. Once again, it's been a hard week. So this is Attack Tactics 5 from Zero to Hero Hack live demo. By Kent and Jordan. But more importantly, this is not just the people that are on this webcast. Me in particular, I did nothing but say, hey, we've got to redo it. We had an amazing support network. Can we do it now with more feeling? We had an amazing support network. Can you guys talk a little bit about our interns and all of the amazing work that they did putting this together?
Sure. Been working with 4 or 5 of our, as John said, interns, plus Kent and Derek. So basically, kid named Levi just joined us. He helped me log in. He wanted to know why you wanted a bunch of sessions logged into random systems with closed things. Jake has been helping us a ton. He's kind of the full-time intern wrangler.
Yep.
So he helps make sure the tasks that are handed to him are appropriately delegated in that mix. Tristan's one of the smartest kids we've had around. He reminds me of when we hired Logan, just too smart for his own good, knows everything.
Yeah.
Let's see, we got Brett Tan, who's helping me write PowerShell scripts and teaching me things that I didn't know. It's a
James
great
too.
crew.
And James was helping us. We helped sell some GoPhish stuff over the last year or so, making that rock on. So definitely everybody's hands-on on this, and it's come a long way.
Yeah, and some people will be like, how hard can it be to actually hack stuff? It's really hard to set up an attack path all the way through and make it reliable, consistent, and more importantly, we can actually log it. You guys want me to take the slide, or you got it?
Tactic 5. We're excited about this one again. Not quite as excited as yesterday. We're a little.
Well, yesterday I was damn near peeing myself through the whole. So this is a little bit easier. So as part of this walkthrough, you're going to have some people that are red teamers, and they're going to be like, "That's not a red team." No, it's not. It's actually demonstrating a penetration test, and they're going to say, "Well, everything you're doing is incredibly loud." Yes, it is. We're trying to go through an entire attack in less than an hour. So if anybody here is like, well, you should have been more stealthy, you're an idiot. We're not gonna be like, okay, Kent, Jordan, could you guys set up the password spray so we have a 15-second delay between each attempt, and then we'll just all sit here for 4 days and wait for it.
Yeah, more like thank you.
Yeah. It is also, to be a good point, we are not covering how someone goes about bypassing antivirus products. We have a series of webcasts called Sacred Cash Cow Tipping that covers that. You can go and review those webcasts The AV bypass technique was a custom HTA file that was created by our very own Geoff Thayer. He's kind of the forge master at BHIS, and he creates custom malware for us and actually modifies payloads so they work. So yes, this is absolutely going to be loud. It's going to be very, very fast, but it's going to articulate from beginning all the way through the end. So next slide.
Agree. And yes, Geoff's work is amazing. We really, really appreciate having him around. And he was on yesterday.
So a little bit about our infrastructure we have set up again with that WinLab. It's Active Directory domain, 300 users in there, 35 workstations. Got Exchange 2013, which will be finding the OWA instance on that, and OpenVPN. So those are kind of some of the things we have in there. But this infrastructure is not without its problems. They've got some public OSINT information about the company we're targeting. We've got weak passwords in the system, or at least a weak password policy. There's phishable users, users that may click on links without thinking too much about it. LLMNR, which we'll talk more about.
Or maybe they do get excited and actually want to click, because that's even more important.
Yeah, that happens.
We're talking about SMB signing, not required. And we're going to say something as
Crackmapexec.
Crackmapexecable.
Is that
so right? I've with that word all day long. And an abandoned internal SSH server, which is interesting, but not unheard of. It comes down to an internal network, making sure you know what's on your network at all times. And as things need to roll off, you properly remove them from your network. So,
and I would say, guys, that we see every one of these problems regularly. It's rare for us to see every one of these problems in one customer. I say that even though last week we had 2 customers that had almost every one of these issues. And they were arguing on their criticality. We were like, you're critical. And they're like, are you sure it's critical? I'm like, yes, it's critical. What makes you think it's critical? Because out of all of the customers we test, you are one of the only ones we've seen that have all of these vulnerabilities that are in every capture the flag that's ever come out. So yes, we do see these. It may not all be manifest in one company, but we see all of them at different points.
Yeah.
Yep. And I would also like to add, I'm only allowing myself to use the word contrived once already. And then the fact that, yeah, this is a contrived network. But again, as John said, we have seen every single thing in this test, either at CCDC, in a customer environment, or who knows.
I wouldn't say we went out of our way to make it contrived either, because a lot of this is at like a default setting. So unless you've gone through and properly hardened things, you're still sitting at what would be this contrived network.
Yep. Exactly.
So yeah, you want to talk about this?
I want to
sure. Well, so
I want to do props for Kent on this. I'm sorry, I have to give Kent props because the webcast was insane. I think Geoff said it's like driving down the interstate at 100 miles an hour with all the windows open. That's kind of what 300 miles an hour. And Kent thought about it, and I thought about it, and we both kind of made changes, and we decided slide deck, even though you guys were like, you want the slide deck? I'm like, hell no, let's do it live. And you're like, are you sure? Of course I'm sure. And that was a bad idea. I was like, get in the car, put your foot on the gas, let's go. But Kent set this up. And Kent, can you talk about like the upper right-hand corner and like the stuff? Because I think that the slide layout is important to understand where we're at.
Really?
Yeah. So what we have to recognize here is we're doing like a much abbreviated pen test, right? And there's a lot of steps involved with that, but typically you hear things like reconnaissance and scanning enumeration, gaining access to lateral movements, or escalation and then pillaging things, right? So we've kind of broken that out, and it's not like a linear race just straight on through. What you'll see here is I'm highlighting the section that we're working with and then kind of the subsection that we're working within. And you're going to notice that that jumps around a lot. We're going to be working linearly as we would a typical pen test to a certain degree. Mm-hmm. However, you're going to notice that we might be working on reconnaissance in one section on the first slide here. And we're going to go to scanning and enumeration. But then, you know, later on, we're going to be working on gaining access, but we're going to have to go back to scanning. And then we're going to do lateral movement. We're going to go back to scanning and then back to gaining access. And it's going to jump around quite a bit. And that's very typical, I think, of pen tests in this scenario, is that you're constantly learning things throughout the engagement.
Ooh, shiny object.
As soon as you learn something new, you're like, oh, I got to go check that out really quick.
That shiny object, I need to scan and enumerate behind that too.
Yes, absolutely. And any one of these can end up being a rat hole that you can spend a lot of time at. So I try to make this as navigatable as possible here. We're also going through and trying to stay with that linear track as much as we could. I'm adding a what we know section on there on the right-hand side. So this is reconnaissance is where we're starting at, and we're gaining what information we gained from the reconnaissance. And then I've got a little legend there that kind of tells us. So every step of the way we go, we're going to be working on what we already learned. And you're going to see that process go through here as we gain information. We're going to utilize that information. And I tried to highlight that information accordingly so we can kind of talk about or discuss how we got there and why we're there and what we can do going forward.
And I think
maintaining that table was fun.
But I think that Jordan said it best yesterday, where he said, we're not going to cover reconnaissance at this point because reconnaissance would be its own webcast. It takes a tremendous amount of time.
Mike just did.
Yeah. So with all of this that we have, they basically kind of broke down. These are the tools that we would use to do reconnaissance. And then these are the results that we have at this point. You said 212 user accounts. We've identified their mail server. We've identified their VPN server. We've identified a number of different things. And now part of that reconnaissance is it's going to become the fuel that you're going to put into the actual attack methodology that's going to follow in the next few slides.
Exactly.
Interestingly enough, the company profile we're working with here is farm, ranch, and organic produce. So that will become relevant later on in the webcast.
Were you kind of targeting like Erica and I's like farm and ranch and organic? Like, go ahead, keep going.
There's large corporate ranches around.
Yeah, they had goats and pigs, and
that's
that
us.
thing right there.
Okay.
That slide.
It is.
And that's how you hack John's farm.
Right. You want us to run through the tools and each of them, kind of how they work in less than 10 seconds?
We don't have time for that. Like you said, this is a whole other webcast. We have a whole bunch of other tools.
So here's where we are, right? John put these slides in to help us recap and understand, right? We don't exactly know where the firewall is. We think it's sitting at this place. We could probably see from the inside. We can't see from the outside. We found OWA. We found a VPN.
Found
and now
something
we're
else.
looking
Whatever.
to find that other service and move about. But basically, the first thing we're going to run is the spraying toolkit. This is part of a password race we did yesterday, right? We ran Mailsniper in one window, and we ran the spraying toolkit in another. And they definitely come close to racing each other approximately the same rate.
So what we're doing is a head-to-head race between two password spraying utilities?
We did it yesterday.
We did it yesterday, and I said, please don't do it today.
Yeah, it didn't. I mean, it went perfectly well, but
without context, it went perfectly well.
Yeah, without context. So we're staying to the slides now, right? We're looking at the spraying toolkit because it's very effective. It's threaded, fast, and it has a single advantage over Mailsniper from our perspective, watching them side by side yesterday, that John pointed out, and that is that as we watch the spraying toolkit, now that it has been executed, you can see, I believe I found a successful credential or a failed credential.
So when this is running, I've got a couple questions for you all. Now, with this tool, you tried it with if we're going through the syntax, Python 3, atomizer, OA, and then we give in the portal, and you put in a password of Dakota 2019 exclamation point. Can you talk a little bit as to why would you use that particular password in this particular context?
Absolutely. So in our company profile, the company resides in South Dakota, and in the year is 2019. Now, that seems contrived. However, it's not unusual for us to have a password like Spring 2019 at this date, or Spring 2019 bang, because that has, the 3 or 4 different character types that you need for a Windows password if you have complexity rules turned on. However, it's not a long password, and at the same time, it's a possible password. This is a password that we could come up with if we were to create a word list off their website, for example, that type of thing. It's not unusual. There's nothing stopping us from here using Spring 2019 bang and having the same sort of results that we do running this. In fact, that's a typical one that we try during a pen test, is the season year with bang after an exclamation point.
So, and these are the 212 users that we discovered through Recon, which we didn't demonstrate here because that's a whole nother webcast yet again. And it looks like we got a credential. Surprise! Yeah. Maxine James?
Yes. Maxine James, yes.
So we have Maxine's account now, which is a very good thing, meaning now we can go look. Okay, we just password sprayed an OA portal. It looks like the credentials are valid, and the tool, I haven't tested this against a 2-factor portal, but the tool thinks we can just successfully authenticate, which is fantastic. So we believe we have our first credential to get to the environment.
Nice.
Now, we're going to move over in our slide deck to kind of what happened here. Again, recon, users, password spray using atomizer. Boom, we have a credential against an OA portal.
Absolutely. And if we go back to the table, which I'm now seriously thinking that methodology table needs to be in every pen test report that we do. It has. I knew you guys were gonna love that. But we have, blame Kent. So the phase that we just did is we've already gone through reconnaissance and scanning and enumeration. We're now gaining access, and now we're gaining access to that environment. We got password spraying toolkit, and now we're going to try Mailsniper, and that's doing the same thing. So while you're setting this up, I want to talk a little bit about threads, and I want to talk a little bit about why you would want to run two separate tools. So many people in testing, they get completely locked up on the idea of the best tool for a particular activity. And that's a misnomer. Whenever you're testing, it's not uncommon for us to run 3 different web scanning tools. It's not uncommon for us to try a number of different tools to move laterally. Sometimes some tools work better than others. So we need to be able to have that. Also, threads and speed is important. Whenever you're trying to run an attack against an environment, some services like Telnet and SSH, they will puke if you have over like 4 threads, actually even over 3. So throttling that back makes a big difference. So here we've got the threads that we're setting up as 10. Is that correct?
Yes, there's 10 threads on there.
Yeah. You see what happened here?
Did this just happen?
Are you
kidding me?
No, of course.
Who pen tests off Windows?
Yeah, who pen tests off Windows? Kent was complaining about having to use Windows at all on his system. So yes, this is actually a tool that has been written by Bo Bullock. And yes, there are signatures written for this particular tool with Mailsniper. And this is a great point, gentlemen, to highlight the concept of hacking naked. When we pen test, a lot of times we will disable antivirus, we will disable firewalls because they will mess with our tools. So we've got Mailsniper running there. That was a beautiful little example of that.
Look at this. I'm thinking, oh my God, what happened to the users file?
It is interesting though. I mean, I say that who pen tests off Windows, but really I do. It's just like you said,
right?
Yeah, it's hacking naked. It's in a VM, and we've got all those protections turned off because we know we're working in a sensitive environment. So
yeah, and this is also different. Jordan, can you bring up the spray toolkit if it's still up? If you don't have it, just let me know. This is what I brought up yesterday. One of the cool things about spraying toolkit is it's saying authentication failed, authentication failed, authentication failed. It's nice because we can see it's working, and that's not saying. You know, Bo, you suck. Start a Marcello. It's just a difference in preference. I know for some testers, they just want to see the results come out. They don't want to see every single attempt that goes through. I know Bo's going to see this, and then immediately he's going to be like, well, now I'm fixing it, and I'm just going to give a verbose option.
This is like with Metasploit, modules in Metasploit, you have the verbose option. You can set to true, and then you get all of the failed attempts. I think, John, there's a question yesterday, too, about we're password spraying and how that relates to account lockouts and that type of thing.
Yeah.
With these failed attempts.
Great point.
Go ahead. You want to speak about that?
Yeah, I'll talk about that. So we have a number of people whenever we talk about password spraying. If spraying toolkit, it tried 212 attempts. You're not going to lock out any of those accounts in most situations. And by most, I mean 99.9998%. Of the organizations. And the reason why is we're trying one single password against all of the accounts that were enumerated as part of the recon phase. And that means it's not going to hit that 3 or 5 bad password attempt ceiling and then lock that account out. Now, your user behavioral and entity analytics platform, or if you're using Office 365, they have cloud security where it can do that type of behavioral analytics. It should detect that. So let's not wait for a Mailsniper. Let's go ahead and let's just move on. And we can come back and we can show it.
Another interesting thing about that is the observation period. And I have actually tested a customer whose observation period was set to 0 in their group policy object for password management. Meaning if I set it to 5 invalid attempts and also set it requires an admin to touch this account, 5 bad guesses against that account over infinite period of time results in account lock. So again, here's the gal.
Got one.
Yeah, we can go get the gal with Maxine's account.
Yep.
So we're taking the
Download a whole
credentials.
bunch of users.
So what are we doing here? Which one are you doing? Are you actually dumping the?
We're getting the global address list, as this slide says.
All right.
Meaning, let's go get the entire list of users so that later on down the road we can fish them all.
Congratulations! That's the first time I think anybody in the history has ever told a SANS instructor, "Well, it's what's on the slide." So well played, Sarah. So we're downloading the global address list. Why would we pull down? So if we go to the syntax of this command, don't jump off this quite yet. We're invoking password spray OA. Okay. We're providing a user list, and then we've already got a user ID and password. But then the second one, you're saying we're going to pull the gal. So you're basically saying get global address list. At this point in the test, we already have an account. Why would we want to pull down the global address list? What does that buy us at this point?
There's a couple different things. One, we did get 212 users from Recon. When this completes, we'll have 214, which means we gained 2 somewhere in the mix there. Some of that's going to be from whether or not accounts are hidden or they're more secured from outside external view. There's some other things as well. Once we have a clear picture of all the different accounts, that means later on when we go to do our password spray, or if we want multiple levels of access, we'll have a little bit more opportunity to get there. We'll have a better visibility of the entire network. So as opposed to just, say it wasn't 212, say it was 5, and we just got really lucky with one of those 5. This tells you go from 5 to 214. We're going to expand out our opportunity and threat vectors.
Cool. Exactly. And generally, if we gain a user credential from Recon, the difference between the number of users we start with and the number of users we finish with is significant, right? We can go from a couple hundred and an account to your entire domain's 2,500 accounts. Trouble. Now we've got more creds. We can expand further, as Kent said, laterally.
And that's why it may look like we're spinning around in circles, but we're constantly feeding what we discovered back into a previous phase and trying to enumerate and expand out. All right, so now this is pretty stupid simple. This is probably some of the easiest hacking we're going to do today, right? We have valid credentials, and what are we doing now here?
Now we're going to go check her mailbox, right? We want to know that we can actually log in as her. I mean, it appears everything is successful. The Mailsniper seems to be kind of hanging in the background, thinking pretty hard. We just want to make sure in our web browser we have access to Outlook, okay? And this is looking good. It looks like Outlook's going to come up for us. So now, that's good.
I have to let you guys know, when we did this live yesterday, you were like, if you do not have 2-factor authentication enabled, you're probably popped already. And you didn't mince any words at all with that. I have 3 emails in my inbox from people that said, I had no idea it was that easy and it went that fast. And they say, we're now implementing 2-factor everywhere. And I'm like, that's great.
So we're just showing that you can get into Outlook at this point with the mailbox that has nothing in it. Most users' mailbox don't have nothing in it, double negative, but this contrived environment does. However, to that point, how many of your users have passwords to other systems that are stored in their email? They do password resets, that type of thing, and there might be a password in their email.
Nice.
We're able to get to that email externally. So
yeah, and I talk about weak password policy a little differently than our findings are generally written. Our findings in the reports we hand to our customers discuss password policies mattering from the perspective of a domain administrator implementing a group policy object with a strong password policy. Much more important than that is us finding passwords in email, also a significant part. So when we talk about a password policy now, we need to be talking about password storage and maintenance, the length of passwords on your environment, how users access password managers at this point, right? A password policy isn't just better than 8 characters. It's where you keep them, how you keep them, who has access to them, how they're protected.
Did you say better than 8?
Another big point on this is, let's say that the Office or the Outlook portal was 2-factored, right? We can still password spray OA portals. We may not be able to get past the 2-factor, but if we can correctly identify passwords, we can reuse those. And I thought we had the VPN up and running right here. And if you have 2-factor for the email, but you don't have 2-factor for VPN, this can happen.
Exactly. Then we log into the VPN portal, which we discovered during Recon. We find our user. This has done this to me a couple times. We'll just reconnect one more time. Our wonderful Maxine. Or bad password. But again, is it Maxine's fault that she has a bad password, or is it an organizational, cultural, security problem generally, right? You allow me to create a bad password, I'm going to do my best to create the worst password I can.
Yeah, because it's the easiest to remember. And if we're tracking the legend over here, right, we know that we have 212 user accounts. We used access to the valid creds to the VPN, the OO portal, and now, as he called out, we just gained access to the internal network. And we can VPN in at that point. Now this is kind of where we scatter out a little bit, right? We're going to do multiple different things in order to gain access to that network. So, oh, there's the global address list. Pooh.
Yep. So now we have the 214 we mentioned in this email, which is awesome. A great place to start. We will turn that into a template for GoPhish here in a little while. Obviously not during the webcast. We give you a CSV, boom, done, up, running, off. But we are going to show you another interesting thing here in just a second. We believe we have internal network access. A quick recap, John.
Yep.
If you don't mind.
So quick recap. I like to do this because we can talk about where we're at and color coding it, but it also helps to show from a map where we're at. We're still on the outside of the network. We can gain access to the VPN. We can gain access to the OO portal, but now we're actually using those credentials to gain access to the internal network. We still don't have access to any machines on the inside of the network yet, but it looks like the VPN is successfully connected. So we now have
looks like we're up, which is awesome.
Yep.
Pretty much any VPN tool you find somewhere, you will find the logs associated with the client connection. The client connection will then add routes, the things you have access to, your destination interface, what you're going to talk to get to these networks. So we see all that stuff in here. And then from here, we're basically going to make our next step.
I will say, John, something interesting about this OpenVPN connection. We say it's not 2FA, but it actually is. Just not the way you think it is. Yeah, there are certificates stored inside that profile we downloaded to connect to the VPN. So that is there. However, because that OpenVPN interface is available to the internet externally, you can download that profile and hence receive your second FA.
Yep.
So now we move into the point of, okay, look, hey, I found interesting networks inside. What do we do now? What do we do with these?
So what we're going to do is we're going to run Nmap, and a little keynote here. This takes a little bit longer than we thought it would. We thought this was going to take a couple seconds. So I think Jordan will probably kick him off, but we'll just switch to the next screen right after we do.
Yep.
Essentially what we're doing is we're taking those routes that were identified in that VPN connection, and we're going to scan and identify all the live hosts using Nmap. And that can give us additional information about the network topology, what systems are out there, and that type of thing. After we just kick these off, we're going to then go into actually identifying the services and see what we can pivot into.
And
yeah, as you see here,
this goes into it's really a child's thing, right? You know, we know the cake's done. We aren't going to sit in the show and watch the scan complete and watch the cake cook for 45 minutes or whatever. We're going to pull it out of the oven and be like, oh, hello, look, it's done. So we're finding,
so that was our server subnet, right? Well, I just stood there and told you, well, there's our server subnet. Look what we got. We got some basically closed services on that box, but somewhere in here we got 14. Looks like
got some SSH servers.
Mail, right? That's interesting. We have DNS, open, and a DC. So we've identified some DC names. Here we'll go ahead and I think I hit Control-C. We'll drop one more command in here and run this against the other subnet that was listed in our VPN connection logs.
And right now we're doing this all over the VPN, right?
Yes. So we are outside the network from our attacker position, authenticated access to the internal network, though we are still not inside.
With Windows. Because we attack with Windows.
Yes. Now, and I would caution anybody that's testing, be very careful over scanning over a VPN. The Nmap scan that they're running right now is just about the most aggressive Nmap scan I would recommend on this. And even on a customer network, I don't think we do T4 over a VPN. We just wouldn't.
No, not generally. And sometimes even inside, if you pick on too many hosts with scans like that, you can definitely make switch cam tables very angry.
Yeah.
And for pen testers too, you know, the client might give you a bunch of internal subnets and you have no visibility into what that infrastructure looks like. That might be traversing some very slow WAN links. And consequently, when you go and hit those with something like Nmap, you could tank that entire switch, that entire link, and cause them some really bad downtime. So be aware of that. Just because it's internal doesn't mean it's all LAN at 10 gigabit.
Yeah, great. And so all of these commands will be provided, as we discussed, we have rewritten them several times. We are comfortable copy pasting the commands out of our document, and we will provide them as part of this.
Oh man, this could be like 5 blog posts.
Yeah, it could be easy.
There we go. So now, okay, here's an interesting place to start. Find open. We want to see the results of that scan. We're going to look at the greppable Nmap file and find open sockets. Oh, brilliant. But what can I do with this? All right, here. This is looking kind of painful. Let's just go ahead and add something like, oh, I don't know. Is there any SSH available in the environment? Oh, hey, look at that.
Look at that. Just open SSH. Yay. Well, it also has, it has Telnet open?
No, we couldn't find Telnet anywhere. It might be.
Sorry,
though.
it said closed. Sorry, I misread it.
Are there any
23? What the hell? Oh, closed.
Yeah.
Long. It's been a long.
Are there any interns available? Is that what you're
Yeah. They might have that in there. Who knows? So then we run our open command to see, okay, hey, look, my bad. Are there any SSH ports listening? These are always interesting systems and something worth investigating. Why, I mean, why wouldn't we go try a brute force script? So that brute force script, whoops.
Do we have a nice?
Yeah,
so we're gonna
right here. We're gonna run that real quick. This is one of my. Sorry, John. Go ahead.
I was just gonna say now what we're jumping into. You probably already saw at the slide is we're jumping into a Kali box. It's rare that when we're pen testing, we jump straight into a Kali box and it's like, hooray! It's like this is so nice. I love this company. It's like, what are you guys using the Kali box for? Well, it has Apache installed on it. We just thought it would run our HR server on it. But
wait, what?
We've got a bunch of SQLite servers wandering around. So yeah, this is the SSH brute force tool, and basically what it gives us is an opportunity to go test a whole bunch of creds without having to touch the box, right? Well, let's tell Nmap to do it. It can do approximately everything you want on a network, so why wouldn't we craft a user list and a password list and have it do all the hard work and heavy lifting for us?
And once again, in a real test, this would be low and slow. We would not do it quite this way. We got some credentials to our mock Kali box.
We have valid credentials.
Yes.
And this gets us to the Kali box John was just talking about.
This isn't that unusual to find an abandoned service out on the network, something that's been there for a decade that's still running on an open system. And that's not that unusual. Is it unusual to get the password for it? Well, it's 10 years old, so you might be able to get a password for it by guessing.
Exactly. Or even more common. You make another point there. Linux boxes are often treated as these are impenetrable, there's no vulnerabilities, you can't break into it, and why would I bother patching it?
Yeah.
So that is very common for us to find unpatched Linux systems left alone or abandoned, quote. So now, right, we got into the VPN, we enumerated services, identified services we were interested in, brute forced those services with authentication, and we're about to jump to a box in the internal network. So as John says in this recap slide, we're going to install some tools too. Our favorite tools, things like Responder, Crackmapexec, things that really come in very handy when you need to test the security of environment. And since this is a pen test, here we go.
So this is on that system that we just got the password for.
Correct.
Yeah. Right. So now we're logged in.
Here we are.
All right. And once again, I know people are going to be like, but it's a Kali box. This makes it easier because we don't have to fight dependencies. Like if it was some kind of weird CentOS system and we want to install our tools on it and be like, God, no, Kali's just super easy. It has the dependencies because this is contrived and we're making our lives simple. So don't hate on us. 7
delicious,
times.
John.
That was the C word. All right, what are we doing here?
Yeah, we're doing some Nmap script. This is without a doubt either the first thing I do or the second thing I do, and the other one is test for LLMNR. Every single test now, no matter what, you drop me into your environment, I'm testing for LLMNR and I'm looking for message signing. If you're enforcing message signing, my attack path is very different than if it is not required, because this means that I can now on another box or the same box go test for things like LLMNR because, well, it's dangerous.
And while you're bringing that up, I'll give a little bit of background on link local multicast name resolution. So what happened with LLMNR is, let's assume you're on a network, right? And not as an attacker, you're just on a standard user, right? And let's assume that this is a Microsoft network way back in the day whenever they're developing Windows. And let's assume that there was a lot of cocaine that was snorted during that particular week. And if you were in Microsoft, whenever they developed the idea for link local multicast name resolution and crack, like just coked out of your mind, somebody at some point had to have said, dude, what happens if DNS is down? How are systems going to find other systems? And they're like, I don't know, man. I don't know. And they're like, wake up, break out of it. And you're just like, okay. So we're going to develop this service. And the way this service works is if you cannot resolve a name, right? If you're trying to go to file server 1, right? And DNS isn't giving it to you. So you can shout out to every system on the network, hey, where's file server 1? And then some system that's on that network will respond back to you with that IP address. No validation whatsoever. It's like that movie Rat Race, buying a squirrel. You're taking bad advice from bad people. So what they're setting up now is they're setting up Responder that can take advantage of using link local multicast name resolution to lie to systems and send them to places you don't want them to go.
Generally the attacker system, right? I'm going to actually send you an authentication challenge for the system you request. And if that protocol is appropriate for authentication, like SMB, NTLM, I am going to go ahead and poison it, challenge you, accept that response. And then let's go ahead and recap real quick, right? We got in, we checked for LLMNR, it's there. We scan your systems for SMB signing and it's not required. So the next attack, this is creds in 5 minutes on a pen test. And this is no joke. I recently talked to a customer, day 1 of the test, it's noon. And I'm saying, there's some weird stuff going on these systems over here on your network. You might want to take a look. And they say, what are you doing over there? Well, you allowed me to quickly relay credentials and gain access to everything on your network. Sorry.
And we're doing this because Responder is essentially replying to every request on the network saying, yeah, that's me. That's me. Yeah, over here.
Yep. So then these 2 services in the configuration file need to be off. We're going to just quit that. We are going to go ahead and run Responder now in actual attack mode. And we'll get our second Windows session, or our second Kali session up here. That one's running. Let's get one more, bear with me. That one died.
And you'll notice there's someone is requesting file 17, which is the 17th file server in ordinary file structures. I don't think that made any sense, but it's probably someone who typed in a server address incorrectly.
And because no Windows system has ever stored a file reference in its registry and left that behind. So then here on the left, right on the right now, we're actually running Responder in attack mode. On the left, we're going to jump into an NTLM relay session. Right, we want to set this up and launch this so that users' authentication challenges will be relayed to systems that we know don't have signing, right? So we've designed a targets file. As you see here, those targets are now going to be relayed.
So do you guys? Those targets are ones that we pulled out of when we did our discovery.
Correct.
Yep. Okay.
So we ran Nmap, check for message signing, pull those system IPs, craft a targets file, and then start respondering, reflecting authentication attempts around the network.
So do you guys know why you have to do relay? Just out of curiosity, this is just a weird trivia history question.
Please educate us, John.
So I got a question. Why don't you just reflect it back and gain access to the system?
The source system it came from, is that the request?
Yep. That was, yeah. So years ago, back 2008, you could actually reflect an SMB authentication. So what would happen is they would try to authenticate to you. You would grab their hash and just reflect it and then gain access to their system. And Microsoft patched that. It was around the same patch as 08067. The main vulnerability was used by Configure. They actually patched it that you couldn't reflect back to the system, but it still works if you relay. So this has been something that's been around for years. So that's why we have to relay through, because if you were to reflect back to the system, it doesn't work. Microsoft patched it.
So let's talk about this, Jordan. What did we gain on the right-hand side?
We're more interested on the left-hand side at this point.
We are, but
yes.
right triggered, yes.
Had we left services like SMB enabled in LLMNR's conf file or responders conf file, we would have gained authentication hashes for which we have challenges and we can go crack now, attempt cracks against. But instead, on the left side, we reflected user authentication attempts against systems. What NtlmRelay does when it makes a successful connection is dump hashes. So on the left, right, we see some systems we tested against. 101.241, 101.238, 101.241, 101.237, and then boom, we get a success, which is excellent. And then we dump all the local hashes. So here's an administrator account. Here's a WinLab account. This one might be interesting, right?
The it admin.
And then we have more, right? So we hit another system and 238, we got hashes off 238. So we start looking around and
we see that admin account.
We've got this LAIT admin account, which is a fantastic place to start. So we snag hashes, my bad.
That means Los Angeles.
So
right?
while you're copying the password hashes, just again, on the right-hand side, we're using Responder to send systems that are trying to resolve files. Like you saw the file server, file 19, file 19, file 19, file 18. We saw systems that were trying to resolve systems that did not exist anymore. As soon as Responder comes up, it now responds to those requests to non-existent systems. And instead of sending them where they want to go, we're sending them to the left side where it's doing the relaying and it's capturing the password hashes in that process. So it's really two different attacks that come together like peanut butter and chocolate that allow us to steal the hashes in that authentication.
John, can you talk for a second why we're able to pick up hashes just by a system entering in a wrong host name, why that would produce hashes for an adversary like us?
Well, there's a couple of reasons. If we go back to, we've talked about this as testers, we seem to find that administrators and security administrators and desktop administrators, they tend to be the ones that have LLMNR enabled far more than anybody else. And our theory is that in most corporate environments, they've disabled that via group policy or part of their standard build, usually through a standard build. And that secure build. But a lot of security administrators and IT administrators, they don't want the standard build. They build their own from scratch. And by building it from scratch, a lot of times they forget to actually secure it by shutting off really stupid services like LLMNR. So that's why if you see like an administrator hash, you're like, well, that would never happen. No, that's almost always what happens. We almost always get a high privileged account because a lot of times it's someone that screwed up when building their system from scratch. So here we kind of draw it out, right? With the attacker out on the firewall, we have initial access to the system. We're running a responder to attack link local multicast name resolution. And then we capture that SMB request, and it was actually to a number of servers. And we relay that NTLM authentication. And NTLM is the same thing as LM, landman, challenge and response. It's the same, it's just the difference is the hash that's going to be passed is the NT hash. And it isn't wrapped in like NTLMv2 with a bunch of other things. It's fairly easy to extract it and reverse it. It's actually sent with a 16-byte challenge and then the response. But because we're in the middle and that's all sent in clear text, we're able to reverse that relatively easily and pull that out. So now we can forward that access to another system, and we manage to get the password hashes for that IT admin system as well.
Now, there's something here that happened in the background that we didn't see, and that is the NTLM relay, the hash that we were using was a local admin on one of those machines. Is that correct?
But it wasn't the administrator account, which I thought was interesting. Because you cannot authenticate with like PS exec to the local administrator account anymore on Windows computer systems, anything with the RID 500. But it's very common for us to find other accounts on every single workstation that is an administrator, but it's not the original administrator account, and you can still authenticate with those accounts. Yep.
That is very interesting.
And there's always, John needed to have access to install printers that he brought in from home, and because of that, he had to have
local
admin access to install print drivers. Yeah, and that's one of those things. Depending on who it is, they might end up with global admin access everywhere because they jump around to multiple computers. But it's not unusual to have someone to have local admin because they need to install software, and it was the least difficult way to get them the ability to install whatever you need.
Stop complaining.
Another point, we aren't running Bloodhound in this situation. And I know there's people that are going to be frustrated with that. We love Bloodhound. The folks at Spectre Ops are amazing, just great people.
Absolutely.
That should be its own webcast, to be completely honest with you. It should be. We're not cutting it out because we don't like it. We just don't have it in this one because we honestly don't think we can do it justice in the time frame that we have. But that will be coming in a future webcast, so stay tuned.
Yeah, and I would like to point one more thing out about SMB signing. If you don't believe this is a risk to your organization, or you're worried about the impact to file transfers on your network, give us a call or an email at consulting@blackhillsinfosec.com, and we would be happy to give you a pen test. And this brings up one last point. A lot of the IT folks we work with on these pen tests drop us directly into secure space, right? Like the center core network, where all of them are doing their business. They're logging in and out of systems as their own admin accounts. And this generally helps us get to your stuff faster. So again, yeah, if you're worried about the impact of SMB, let us demonstrate.
Yeah, and that's kind of the reason why we do these webcasts, right? And there was a ton of people that shot me emails and they're like, yeah, I want the slide so I can demonstrate this in our organization. So Crackmapexec, this is, I believe that Marcello has referred to the issue tracker and Crackmapexec as the, what do you say, the 4chan of GitHub. But this tool is stupid awesome. And once again, we should have an entire webcast dedicated to Marcello's tool or Byte Bleeder. And once again,
he's got so many things.
So I don't think
so many things pulled in here.
Yeah. So what the hell did he just do here? So what do we have here, folks? Because this is
right.
Yeah, this should make you warm and fuzzy.
Stealing that hash, right? We relayed, we dumped hashes off a system. We figured out that one of the local admin accounts was probably global, and now we attack the entire subnet with a pass the hash attack.
So you're telling me you took that LA IT admin hash that we got from the other user with NtlmRelay.
Yep.
And you're now taking that hash and trying to use it everywhere else to pull more hashes?
Not yet. That's
Not yet.
the next
Okay.
one.
I got a question, but how do you know these systems are pwned?
Yeah, pwned from this perspective means yes, you are an admin.
You are compromised.
And so there's all kinds of awesome things we can do with this tool. Again, this tool itself could probably use a few webcasts, right? He's pulled in things like SMB exec. He is now looking for Cisco Smart installs in it. There, I mean, the guy is one of the most brilliant coders I've ever met. Probably top 5. I can't even imagine
and he's really
doing what he does with code. But let's go ahead and just run the LSA module. Now that we know we have admin on these systems, we're gonna push this hash, authenticate on SMB, right? And this is a hard thing to visualize from a blue team perspective. I just had a whole bunch of systems hit on the SMB socket, right? That isn't logged normally. And now these guys are interacting with the credential material stored in LSAS. Holy crap, here goes my whole domain.
So this is every workstation that LA IT admin was an admin of. You're now using LSA to pull down the credentials stored in LSAS.
Correct.
And that's going to be a lot.
And it is a lot all over the network. And you probably don't want to do this.
I would say don't do this to a domain controller. There's so many other ways to get password hashes that don't involve touching the local security authority subsystem service. Generally, as a rule, I think the best way to get password hashes off is volume shadow copy on domain controllers, and force a volume shadow copy backup, pull it out of ntds.dit out of the volume shadow copy, and crack it that way. But this works really well for this demonstration to show just how many systems we can pull hashes out of.
Yeah, anywhere that account was admin, we have credential material for any user that was authenticated, right? And running through this, the list is seemingly infinite. Up, not too far up, you're going to start to see user credentials. You're going to see administrator. You're going to see IT admin. You're going to see all kinds of other users, right? There's our IT admin hashes.
There's Gwendolyn
Bertha,
again.
whoever she is. Gwendolyn, I think we relayed one of hers. Randall Parsons, whoever that is. Terrence. So we have password hashes for all these people. You could do your text manipulation, send the hashes offline, start cracking. You could try to relay further with these. But it looks to me like we have an IT admin. We would probably go inspect further, see who that is, where they are. But even worse, right? This looks like, you know, one of the big kahunas. That's bad, right? But anyway, that's pretty much game over with that tool. It's that fast from LLMNR, responder, SMB signing, pillaging, Crackmapexec, done, and we're out.
And we talked about this yesterday, John. We went through this in like half hour, but realistically, it takes a long time, right? There's a lot of stuff we did to kind of prepare for this, but it's not unusual to be at a similar spot relatively quickly.
Yeah, especially post-exploitation. I think initial access takes longer with the recon and the crafting of the spearfish and all of those different things. I think that takes a lot longer than, you know, the 5 minutes that we spent on it today. But post-exploitation, once we get that foothold and we start running these tools, it sometimes goes exactly as fast, if not faster, than what we did here. All right, so phishing, huh?
Yep, the next attack, we are going to email an HTA file to the user population.
And it could be argued, why are we doing this whenever we already have full domain administrator access to the entire environment? We're demonstrating yet another way to get into the environment rather than password spraying is what we're doing.
So at this point, we're kind of starting back over. If you'll notice in the right-hand table there, what we know. So what we're going to utilize at this point is much different. We're going to utilize those 212 email accounts, and I believe we're going to use GoPhish. And so all we really have for a starting point right now is a list of users. That's it. We're not going to utilize the fact that we just gained DA to a different method. We're going to kind of start over from the beginning here with GoPhish.
So if you haven't used GoPhish, haven't seen GoPhish, free tool from my perspective at this point. No offense to anyone. It is my favorite phishing tool. Check out Google, SendGrid, GoPhish. SendGrid is one of these companies that Google, Microsoft, Yahoo, all these carriers have agreed, well, you pay us money, we'll land any email that flows through your service in someone's inbox. And so we set up our sending profile. First place we start, we use SendGrid. We set up a landing page, which is a really, really cool tool, right? We go and say, here's a greenhouse megastore. We're going to import a site, whatever site we want. Here's the source code for the site. Here's the site itself. This is, again, where our users.
And how much does this cost?
This is free, John.
Free!
Free, free, free.
Well, I'm suspect of anything free. All right.
And our users and groups. This is where the gal comes back into play, right? We're going to now upload a template file that you can download right here from this link with all the users we snagged from the gal. We're going to hit every single one of them since we know that this is a farm and ranch organic produce organization. Let's just hit them with a fish.
What could go wrong?
I got a question. So this is common in a lot of pen tests. This is not really common in a red team where if we gained access to go back and then fish, right? And I want to explain. I want to explain why. Like in a red team, the goal is to get in and get access to something. It has an objective to it. That is key to any red team. Is there is an objective associated with it. With many penetration tests, we'll actually try multiple different paths to get in. So we'll do password spraying, and then we'll circle back. And if it's in scope, we will do spear phishing, and we will try multiple different paths. We'll scan with Nessus, find vulnerabilities, be a lot more noisy than you would in a red team itself. So that's kind of why we're circling back, because if we were doing a pen test, we wouldn't quit because we got DA. No. We would circle back and find additional paths as well.
Exactly. Everyone ready? Shall we fire the cannons?
Let's try it. Do we have the right S's or lack of S's?
We copy pasted, John.
Thank
funny,
you.
but not funny, John.
We learn things painfully, just like everyone. Right. Another thing about phishing and him pen testing some and me phishing and or him scanning is we're on a pen test operating similar to attackers, right? You don't have an attacker doing one thing or doing all the things. I apologize. Kent's going to do something. I'm going to do something. John's going to do something. All these things, right, are going to be coordinated, and the efforts are going to come at your organization very, very effectively.
Absolutely.
All right.
So one of the things I've got going on that I'm going to look at is seeing those emails come in. So those emails are going to come in, and essentially it's the payload is an HTA file when this comes through, and the HTA file was actually generated initially in Cobalt Strike.
Yeah, but is this still the modified one that Joff sent through his obfuscation tool?
Yes. Yes,
Cool.
that is what we're doing.
Now, it is also, I want to say it's really cool at this point. Whenever you're on a pen test, you've already gained access to their email and you send in the spearfish and you can sit on their email and make sure that it made it through. That makes it so much easier to test these things.
Oh, absolutely. Yeah, just pulling up Cobalt Strike here real quick. Kent will be just about ready to launch payload or launches. Click on those links as a happy internal employee.
Yes, I work for a farming company.
Oh, look, compost.
Kent is actually unlocking
we are good.
The SMTP service on the.
I will tell you, anybody that's into gardening, compost is like crack. They just can't get enough of it.
Yeah, you have no idea.
Oh, I do, dude. We have probably 3 tons of compost up at my place, and Erica is like, "Do you want some?" I know you guys have gardens.
So. Yes, we have gardens and greenhouses.
Greenhouse, you have a greenhouse.
Double wall
polycarbonate roofing. Yeah,
that's a thing.
That's a thing, as I learned,
which is terrifying. Here's our listener.
Do we already have a session?
Yeah. So Bertha opened the email that said free coupons, but to get the free coupons, you have to download the coupon printer, which is an HTA file. And of course, I want my coupons. So I said, yeah, install it, whatever, it's good. And I ran the coupon printer, which prompted me for my email password and whatnot, but no, it really didn't. But what it did do is create a Cobalt Strike beacon.
And this could have been Metasploit, right? We could have sent this in. We could have done Magic Unicorn. We could have done Metasploit. We could have done any number of different things in order to do this. Just we like showing off Cobalt Strike because it's just a cool tool. It's pretty.
Yeah, neat. It sure is. Roth has done some amazing work on.
There's a very, very rare situations where I'm like, this is a neat commercial tool that you should buy. And right now, Jordan's just screwing around and setting up. Now, why did you set up a secondary shell? Like you got one session?
Yeah, I really appreciate this. And this is where I give a shout out to 40 North Security, right? And Chris Truncer's work, his team, and the efforts they did. Every single tester at BHIS has gone through this training, and I don't think a single complaint came out of that. Nope. Chris's work, getting that stuff operational, has turned us all into red team mindset. Yes, this product is the go-to solution for that course, but it is worth every penny for the course, for the training, for the material, for the time John invested in all of us. I can't say enough about Chris Truncer's efforts in that. But we spawn a second session in case our first one dies, right? We got a unique PID, which is important, right? Let's say I do something dumb in this one that triggers AV, boom, blows up that process. I still have a second one. I have another way in.
There's something else going on behind the scenes here. We're using a malleable profile for this as well. So if you were hunting at this point, you don't see traffic that looks necessarily like C2 traffic. What you're going to see instead is, we're using CNN.
Yeah, I think I used a Fox News streaming video profile. So something similar. The malleable C2 profile, this is a really cool thing, right? It's basically a collection of client, server, HTTP GET, HTTP posts, and some variables are required in that file. But the malleable C2 profile is amazing and modifies headers in a way that makes it, as Kent said, very difficult, and it doesn't look like normal C2 traffic.
Especially for traditional signature-based detection. So we got to start wrapping it up, guys. I know that you just want to mess around with Cobalt.
Well, we're not. We just ran a net view, and we're almost there. So we're going to add a view targets. See what happens here over the next couple of minutes, but we figure out, let's run one more command for you.
Shell net.
Shell net group / domain. We're interested in what groups are on the domain.
Mm-hmm.
Let's see if there's anything interesting in here we want to look at.
So back to the slide deck, I think we kind of pinpointed this out because yesterday I did something that John said, don't do that ever, which was essentially after spending a few minutes in Cobalt Strike, I had essentially created a beacon of, I don't know, maybe 10 different beacons. And I basically essentially said, okay, Control A, all beacons, go do Mimikatz and give me all the passwords everywhere. Which is really super noisy, right?
Nothing you would ever do in a normal situation.
It looked cool though. Whenever you got the graph and you took over the entire environment with Cobalt Strike, that was pretty neat.
Yeah. So the other thing I did is I went to the targets. So essentially a list of all the different systems in the environment, Control A, and then I said, okay, go spawn a beacon on every one of these systems. Obviously, huge impact on the service. I'm sure the the WinLab servers started to spin up really fast there. But essentially what we're doing is creating a C2 on all of the servers at that point.
In one shot. And this goes back to, I always like to say, you know, I'm not afraid of the person that wants 100 shells. I'm terrified of the person that only needs one to do that. So, and we've got all those commands in Cobalt Strike here as well.
Yep, exactly.
So let's wrap it up while you're finishing that up, while that's running in the background. Sure. Let's tie it up. We're at the top of the hour. So this is basically really fast going through a pretty low level penetration test. As we said, we don't usually see the vulnerabilities chained together quite like this. But every single one of these vulnerabilities we have discovered quite regularly in penetration tests. It just doesn't usually manifest into one engagement as well. Now, what's next is, a lot of people asked in the questions in the webinar yesterday, what about the defenses? And that's what's next. Whenever we do this, we do the attack tactics. The odd number is the attack, and the even number is going to be step-by-step blue team efforts and how we can actually go through and stop this. Because there's so many things, right? Like good configuration for SMB, using two-factor authentication, having passwords that are not instantly crackable, not getting rid of unknown or forgotten systems in your environment. There's so many lessons to learn.
LLMNR.
Yep, get rid of LLMNR, like now. It still bothers me. Like if I'm on an airplane and I fire up a sniffer, it's like LLMNR, 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 LLMNR. It's like,
I beg your pardon. You do what, sir?
NBTNS, MBTNS,
yeah,
MBNS.
exactly. So
John's gonna be stopped at the next TCA checkpoint.
I am surprised that Microsoft has not come up with a group policy object that takes care of the NBNS part of that house, because NBNS, NBTNS, same thing. LLMNR, you can disable LLMNR with group policy. You cannot kill NBNS. It does not want to die.
No. So we're going to talk a lot about the defenses. And I just wanted to say thank you very much for watching this video. We greatly appreciate it. If you look down in the notes, you're going to see a link. And that link is to all the slides that we went through with all the commands and how we did things. And I think we have to say it, gentlemen. A lot of our webcasts, we talk about tools, we talk about tactics, we talk about techniques. I think that we have to say, don't use what we talk about in this webcast for the purposes of evil. If you're going out and you're hacking organizations using these types of techniques, you're just bad. And even if you're like, well, I'm just curious. No, you're a hacker and you're an illegal hacker, and there's a special place in prison for you. Don't do this illegally. We talk about these things specifically to make blue team better, because at the end of the day, that is the goal of any red team and penetration test, to make the blue team better. We get better by understanding awareness. So thank you very much, everybody, and we will see you in the next webcast.
How do we get the cat to go on cue?
Just like that? We're still recording.
Are we?
Oh,
yeah, it is.